Look up, see it? The moon, our celestial neighbor, a beacon in the darkness. But have you ever stopped to think why it looks the way it does? Why is the moon so brilliantly white? The moon, unlike the sun, doesn't emit its own light. It shines because its surface reflects sunlight. But there's more to it than that. The moon's appearance is a result of a violent and chaotic past, a history written in the very fabric of its being. Let's take a journey back in time, to the dawn of our solar system, to understand this celestial marvel. We'll explore the giant impact hypothesis, the leading explanation for the moon's formation. We'll delve into the composition of the lunar surface, a dusty landscape called regolith, and we'll unravel the secrets behind the moon's changing face, its phases and eclipses. Imagine a time when our solar system was young. Forget the neat arrangement of planets we see today. Instead, picture a chaotic cloud of gas and dust swirling around our nascent sun. This was the chaotic playground where planets, moons, and asteroids were born. Collisions were commonplace. Objects, large and small, constantly smashed into each other. Some grew larger, accumulating more material with each impact. Others were shattered into countless pieces, fated to drift through the vastness of space. It was in this chaotic environment, over 4.5 billion years ago, that a Mars-sized object called Theia collided with the young Earth. This impact, so powerful it boggles the mind, would forever change our world and give birth to our closest celestial companion, the Moon. The giant impact hypothesis, born from decades of scientific inquiry, paints a vivid picture of the Moon's formation. This wasn't your everyday fender bender. Theia slammed into Earth with unimaginable force, vaporizing itself and a significant chunk of our planet. Debris from this colossal collision, a mixture of molten rock and vaporized material, was flung into orbit around Earth. This debris cloud, bound by gravity, slowly began to coalesce. Over time, it cooled, solidified, and eventually formed the Moon we know today. This violent birth explains many of the Moon's characteristics: its composition similar to Earth's mantle, its relatively small size, and its unusual orbit. But how did this cataclysmic event lead to the Moon's bright white appearance? The answer lies in understanding the lunar surface, the lunar regolith. The Moon's surface is not a pristine, smooth landscape. Instead, it's covered in a layer of fine, powdery material called regolith. This regolith, formed over billions of years by micrometeoroid impacts, plays a crucial role in how we see the Moon from Earth. Lunar regolith is composed primarily of rock fragments, minerals like silica and iron oxide, and tiny shards of glass. This mixture of materials doesn't absorb much light. Instead, it scatters sunlight in all directions. This scattering effect is what makes the Moon appear bright white, especially during a full moon. The scattering of sunlight by lunar regolith isn't uniform. The angle at which sunlight hits the Moon's surface, as well as the roughness of the regolith, can influence how much light is reflected back towards Earth. This interplay of light and shadow creates the familiar patterns we see on the Moon's surface, the lunar Maria and highlands. We all know the Moon doesn't emit its own light, it shines with reflected sunlight. But the amount of reflected sunlight we see changes throughout the month, giving rise to the Moon's phases. From the new moon, a sliver of light, to the full moon, a radiant disk, the Moon's appearance constantly shifts. During a lunar eclipse, the Earth casts its shadow on the Moon, creating a spectacular celestial event. The Moon doesn't vanish into darkness, however. Instead, it often takes on a reddish hue. This eerie red light is sunlight that has been scattered and refracted through Earth's atmosphere. Observing these changes in the Moon's appearance, from its phases to lunar eclipses, allows us to witness the interplay of light and shadow on a celestial scale. These phenomena, driven by the fundamental laws of physics, remind us of the interconnectedness of our solar system. From its formation in a chaotic early solar system to its ever-changing appearance in our night sky, the Moon's story is a testament to the power of scientific inquiry. By studying the Moon, we gain insights into the history of our solar system and the fundamental processes that shaped our universe. The Moon's bright white glow, a product of sunlight scattered by lunar regolith, serves as a constant reminder of our celestial companion. As we continue to explore the Moon, both robotically and with human explorers, we're sure to unravel even more of its mysteries. So the next time you gaze up at the Moon, remember that you're looking at a relic of a bygone era, a testament to the power of cosmic collisions and a celestial canvas upon which the laws of physics paint their masterpiece.